Hello, my fellow classmates. Today I wanted to discuss carbon dioxide recycling into methanol for greater energy production and other industrial appliances. How it works is carbon dioxide from the atmosphere from plants such as refineries and stuff get ran through a catalyst combined with hydrogen gas to make methanol, which is used commonly in water treatments, in hand sanitizers, in perfumes, various cosmetics. In methanol, fuel that runs in this bike, it is a very common used compound. It's used to run turbines to generate electricity even. The catalyst needs to be a high activity catalyst. Now, there's various forms out there, but the most efficient is called an Ru-MaCO-BH catalyst. An Ru-MaCO-BH is a novel ruthenium catalyst for homogeneous hydrations of esters. This catalyst is applicable for a wide variety of ester substrates under base-free condition. Several base-liable and chloral esters such as A-alkyl esters and B-amino esters, which provide corresponding optically pure alcohols without loss of optical purity. In a sense, what that is simply saying is it takes the efficiency rate of converting carbon dioxide to methanol and makes it from 77% to 79% by lowering the temperatures needed and using another compound called pentaethylene hexamine. Try saying that 6 times fast. And what it does is it lowers the amount of temperatures needed to convert carbon dioxide and hydrogen into methanol and water. The water can then be taken into a photocatalyst, basically a catalyst that takes UV lights and splits the water into 2 compounds, hydrogen and oxygen. The oxygen can be used for the oxyacetylene torches, and the hydrogen can be used to power hydrogen cars and things like that, as well as one of the primary ingredients to making methanol. The methanol can be burned, and when it is burned, it puts out 2 carbon dioxide molecules and 4 water molecules for every 2 molecules of methanol burnt. That lets you basically create an endless loop, almost, of 79% efficient conversion. Now, 79% efficient doesn't sound as good as it could be, but it's a lot better than 100% carbon dioxide being emitted. Now, to give you an idea of what that 79% could look like, if you take 10 pounds of wood and burn it and successfully convert the carbon dioxide back into methanol using the ruthenium catalyst, that 79% will get you 50.1 gallons of methanol. This is a 5-gallon container that methanol is stored in. So it'd be 10 of these containers, which, if you think about it, is quite a bit of fuel. And this fuel can be used, once again, to generate electricity. It's used in various chemicals and cleaning agents. It's used for water treatment. They pour it in water and mix bacteria in there that, when mixed with the methanol, eats nitrogen from the water and makes it so it's no longer nitrogen poisonous. They do various forms of industry with methanol. It's even used in cosmetics and perfumes. This ability to convert waste and turn it into power is something that people have been after for years, and even car guys do something similar. They take their exhaust waste, put a turbo on their car, and use that waste to spin more air into the engine to push more fuel in to make more power. And in a sense, the methanol would be doing similar. You're taking the carbon dioxide waste and recycling it into something useful that can be burned to remake carbon dioxide waste to remake methanol. It's an endless loop. Now, of course, it's a 79% efficient endless loop, so it sits there and slowly decreases, but that decretion does eventually add the carbon dioxide up enough of that 21% to recycle back over again. And this process is a very interesting process. It uses the carbon dioxide waste to make the methanol, and this is why we should use its process and actually make more plants, because you are powering oxyacetylene torches now, you are powering hydrogen cars, and you are powering methanol production. And methanol is actually cheaper than gasoline at the moment, but on the sad note, it burns about 2.5 times faster, but you also make about a 20% power increase when using an internal combustion engine like this, which makes it worthwhile. Hopefully this helps you understand why carbon dioxide to methanol recycling is so important, and I can't wait to see your guys' videos.